Any volunteers?
I would like to try.
Okay, who said that? I thought you have to tell me.
Kashira.
Fitzgerald. Okay. First of all, I'm writing it down now. If you do something like this, I write it down as extra credit. So, Shira, this is you've done one before, but we're going to let you tell us what you think should be the first step here. Are you going to tell it?
Um, I wasn't sure. Yeah. Add 3x on both sides.
Okay.
Underneath the 3x and negative 10.
Okay. So she wants to get rid of you. I'm going to explain what you're doing in terms of the technical terms. We're this equation is not in the y equals mx plus b form. It's not in the slope intercept form because it doesn't have y equals.
Oh,
So that's the first
that's why I
thing.
was confused. I'm sorry.
Okay, so that's what you're telling me to do. You want me to bring the x's to the other side, so I'll only have y's on one side. And then once I have that, I can divide everything by what's in front of the y to get it in what we call the y equals mx plus b form. That's the most helpful form to write the equation of a line. Okay, so you told me to minus 3x from both sides, correct?
Yes.
So what do we have now? This we get rid of. So what do we
2y.
have? 2y.
2y plus 3x.
Wait, I'm gonna. What is this? I'm sorry.
3x.
Is it positive 3x or negative 3x?
Negative.
Right, negative 3x. Don't forget the sign.
Equals negative 10.
Wait, our equal sign is over here, right?
Oh, wait.
So this is just,
Negative 10. I'm sorry. Minus 10.
in other words, or if you're
Divide.
doing it by the transposing method, since this is a positive 3x on this side, we're going to bring it to the other side. It's going to become negative 3x. Now, what did you think we should do, Shira? What's our next step? Um,
Divide
anybody
2.
except for Shira, please mute yourself because there's a lot of background noise. Um, April, it's
Yes.
okay. Thank you. Okay, Kachira,
Divide 2.
right, we're gonna, since we want the y alone, if we want it in the y equals mx plus b form, we need the y alone, we're going to have to divide this side by 2, which means we have to divide everything by 2. Not just the x term, but the 10 as well. So that leaves us y equals, okay, what do we have in front of the x then?
Negative 3x over 2.
Okay. I like to put the negative 3 over 2 separate from the x. The x can be on top or it can be next to it. The reason I do that is because it looks more like the setup. Okay, and what do we have over here?
Negative 5.
Okay. So now you have your y in the slope intercept form. So what is the slope of the line?
Negative 3 over 2x. And the intercept is negative 5.
Okay. First of all, when you talk about the slope, you don't give the x. X is not part of the slope. The slope is the negative 3 over 2. That's why I put it separate. When you're writing what the slope is, you just write the number without the x. And you said the y-intercept is going to be, you said -5, right?
-5.
Right. So she's accomplished the first part. She found the slope and the y-intercept. By putting the equation, if it's not y equals, then the first thing you have to do is get the y alone, and then you're going to find the number in front of the x is going to be the slope, and the number that stands alone is going to be the y-intercept. Okay, so how do I graph that? I'm going to turn on my light. I'm going to ask you, does that make it clear? Does that do anything to you?
Yeah.
Yeah, okay. Okay, here's my graphic. Here's my x, here's my y. Where should I put the material?
Start from -5, which is the y-intercept.
Right. So we go down 5 on the y-axis. That's always going to be your starting point. The y-intercept is the first point you graph when you're graphing a line. How do I get to another point? What should I do?
Graph -3 going down and 2 to the right.
Right. Since my slope, which we call the m, is -3 over 2, which is rise over run, from here we're rising -3. Well, a negative rise means go down. 1, 2, 3. And run at the same time, go 2 over. There's 1, 2. Here's your second point. Do you want to do another point? Do you have to?
Sure.
Okay.
No, but you can.
Right.
Start from the -5 intercept and go up 3 and 2 left.
Oh, very good. That was a very good idea. When we have -3 over 2, we could also, remember I said, doesn't matter, when you have a negative in a fraction, it could be either in the numerator or the denominator. It means the same as 3 over -2. So if I'm doing rise over run, from here, instead of going down 3 and 2 to the right, I could have gone up 3. My rise could be +3, 1, 2, 3. And -2 run means instead of going 2 to the right, go 2 to the left. If you notice how these points all line up, that was a very good, done very nicely, Kachira. Thank you. And
You're welcome.
that idea, I know this is, the line looks very curvy. That's because it's not done on graph paper. I hope nobody's having trouble using doing it on Delta Math, because there you just have to click on points and then it draws a line for you. Does anybody have any questions before I go any further?
Can you just go over the rule about when the slope is negative again? Like
Okay.
how do you decide if you're going up or down or left or right?
Okay. Let me I'll give you we'll do another example.
Yeah,
okay?
I don't know. This is just really confusing for me for some reason.
Emma, do you have graph paper?
Sure do.
Okay. When you do it on graph paper, it makes a little bit more sense. So I'm going to give another problem. Let's say, and I'm going to put it already in the y equals mx plus b form. Let's say I had y equals -2x plus 5. Okay. Then my slope would be -2, right? Because it's already in the y equals mx plus b form. But when we talk about the slope, especially when we want to use it, we want to make sure it's a fraction. A whole number can always be made into a fraction by putting it over 1. So my slope is going to be -2/1. Remember, this is our rise
Over
run. And my b, my y-intercept, is going to be the standalone number, which is the 5.
positive.
Okay? So when I go to graph that, this drives me crazy because I see when I look at my screen, for some reason my screen gets distorted. So when I sort of draw them right, it comes out very distorted. So you just have to bear with me. This is as close as I can do to graph paper without actually having graph paper. Okay. All right. So Corey, you're listening carefully on this also. I'm going to talk about the negative numbers in a minute. We always start at the y-intercept. So if the y-intercept is 5, it's positive. That means 1, 2, 3, 4, 5. Here's my starting point. Just putting a bunch of tick marks where. Now the question is, I have a starting point on my line. Where do I go next? How do I go to another point so I can actually draw the line? And the slope being -2/1 can be looked at in 2 ways. We can say the rise is -2 and the run is 1. Now, remember, the point of a negative sign is to indicate direction. So if I'm starting, and I'm always starting at my y-intercept, if I want to rise -2, instead of going up 2, I want to go down 2. So that gets me right over here. I'm putting an X. But I don't stop there because at the same time I have to run 1. The slope is telling you 2 things: how much to go up and down, and also how much to go side by side. Since the run is 1, from here, that 2 down, I have to go 1 over to get me to another point. Now, actually, I could draw the line from here because I have 2 points. But if I'm doing it on graph paper and I don't have a good ruler or want to do a better job at that, I can try to get more points. Now, I could get more points by starting at this new point and again going down to 1 to the right. Or I could do, if I could, instead of looking at this as -2/1, I could also look at it as 2 over -1. This is a negative divided by a positive is negative. A positive divided by a negative is negative. In other words, it doesn't matter if you take this minus sign and move it down. Usually it's better to keep it in the numerator, but it could be in the denominator as well.
So how do you decide when to do that?
It's your option.
Oh, they're both correct.
They're both correct.
Oh,
But don't do the minus on both of them.
okay.
A -2 means just in minus, either on the top or in the bottom. It doesn't mean both minus.
But if you see a negative, basically the direction of your line is going to be this way instead of that way.
That'll be going down this way,
Going
right?
to be going down left to right.
That is really your hint. The slope is giving you an indication of how much the line is slanted.
Right.
When the slope is negative, it means as you go from left to right, you're going down. If your slope is positive, as you go from left to right, you're going up. So always keep that in mind so you'll know that you're doing it correct. Notice, let's go back to this. If I wanted to, this is what Kachira mentioned. Instead of going from this point here, instead of having gone down 2 and 1 to the right, we could have then counted up to a +2 got me right here, and then gone one to the left. Now, if I had a really good picture, you would see all of those points actually line up. And there's your line.
I think it's Jonathan speaking, by the way. Good morning. I think my issue was the homework because they was giving us decimal point, they were giving us fractions, and they were telling us to plot the graph, do all that stuff, and it was like decimal points, like 2.5 comma 3, and then find the next points. And that was the confusing part. It took me more than an hour to do the homework. And I think we have a group chat, so a lot of people were confused about the homework.
Okay. What I would say, did a lot of them have, because there's no way I can see all the problems that you get.
Mm-hmm.
Some problems I specifically pick specific problems, but sometimes I just give a random. Now, did a lot of them have, I didn't see it, when I looked at them, I didn't see any with decimals. But
I had like 3 with decimals.
Okay, I would say just skip those.
Oh, okay.
Just go to the next. Because when I give you the homework, and it says do 3, if you don't like a problem, you can just go to the next problem. You won't get, it doesn't do anything to it'll give you the right average.
Okay.
At this point, I'm going to be talking about fractions more today because when you do slopes, you automatically get into fractions. But when it comes to graphing, and certainly when it would come to a test, I wouldn't give you anything that would involve graphing something that had decimals in it.
Okay.
Was it your calculators? What are you trying to say, Corey? With a you mean?
Basically, like if I did some of these problems on my phone, it'd give me decimal points, but the calculator I have doesn't give me decimal. It gives me fractions.
Oh, is that let me ask you, do you notice, let me go back to this problem. Thank you, Corey. I think you explained something that I didn't understand they were talking about. Let me give you another example. Can we do another example? Suppose I gave you this equation. 2x minus 3y equals 9. Okay, I'm going to give you a minute to put this in the y equals mx plus b form. While you're doing that, I want to take attendance. I really want to work this out very carefully from beginning to end. You really have to understand. So I'm giving you a couple minutes to work this out.
Do all this, but again, I don't want to waste time in the class, but it's just one of the problems in the Delta math where they'll give us a blue point and a red point, and they'll tell us to move it around, and then it will be like what will be the next point or something, and it will be like 2.3 comma 1, so the next point will be like 4.6 comma 2, something like that. And that was something that stuck with me for some reason last night. It was giving me immense problems. It was like very confusing. I know Cheryl and a couple other people had questions because it was very confusing.
Yeah. Okay, you know what? Can you send me a picture of one of those problems? Okay. And I'll see. But I promise you, when it comes to a test, it's not going to be. There were a couple that I found a little confusing to work also. But I'll try to give you. You'll see that the next questions are easier to do. Okay. Now that we have this, if we wanted to graph this,
Professor, I understand when the finding the y and everything, but the graphing, I'm a bit confused when it comes on to that part.
Okay, so can we do, let's do the graphing now, okay? So if I look at this, there are two things that are important to me. One is the slope, I'm going to call that the m, which I see is 2/3. And one is the y-intercept, which we call the b, and that's -3. Don't forget, the sign is part of the number. If it's a plus sign, then you don't have to put that sign in, but if it's negative, you have to put it in. When I want to graph something whose slope is 2/3 and whose y-intercept is -3, I start on the -3 on the y-axis. The y-intercept is -3. Notice, even though the m comes first and then the b, when we go to the graphing, we start at the m. I'm sorry, we start at the b, we start at the y-intercept. We have to have a starting point. Saying b is -3 means that 0, -3 is the y-intercept. Now we want to go to other points, and that's where we use the slope. The slope is 2/3. Remember, that's rise over run, which means from this first point that I gave you, I have to have a starting point. From there, I want to rise 2. That means go up 2 because it's positive. 1, 2. Run 3, 1, 2, 3. So let's do it. 1, 2, 1, 2, 3. Notice I don't make a dot over here. The dot comes after I do both the rise and the run. I have to go up 2, 3 to the right. I could have said, and that would have been enough to draw the line. I could have also said, well, this is the same as doing -2/-3, because a negative over a negative, we had that, we know is positive, which means I could have first from this point gone down 2, but -3 means 3 to the left. Now notice these points all line up. There's my line. Is that clearer now? Was it Stacia that was asking that question?
Yes, it's clear now.
Is that clear? Does anybody have? So again, do not make the number in front of the x, the coefficient of the x, into a decimal. Don't make it 1.5 or 0.66. That's not helpful for a slope because a slope is better as a fraction. If it turns out to be a whole number, let's say it turns out that the slope turns out to be -3, then you put it over 1. You want it as a fraction. If it's not a fraction, put it over 1. But if it's you don't want to change it to a decimal. Are we okay with this now?
I definitely feel a little more comfortable doing it. Thank you for the further explanation.
Okay, we'll do a few as we go along. I want to go a little further on what we're talking about, but
I have a question.
yeah, sure.
It's Jennifer.
Yeah,
But
Jennifer.
it's not about this. You just explained this, so now I understand it more. My issue is particularly when we're doing y2 minus y1.
Okay, we'll do some of
There,
that.
when we go there, I have a question.
Okay, so that is, let's work on that next then. Thank you for bringing that up. So what we've seen, number one, we saw how to start with a linear equation. We'll know it's a linear equation because we won't see any x squareds, we won't see any y squareds. And we will, and we will know that we can put it in the y equals mx plus b form. Y equals, okay, so that'll tell us what the slope is and what the y-intercept is. And we talked about yesterday also let me just give you a clear understanding of where we're going with this. Obviously, this whole idea of slope is very important. It's giving us an idea of how a line is slanted. Now, we saw to right now how we found the slope of a line if I gave you what the equation of the line is. There is another way of finding the slope, and that's what I think Jennifer was talking about. What if I just give you 2 points? Suppose I give you the points -2, 3, and the point 5, -7. I'm just making up points. So these might not come out so nicely. I could draw those 2 points. I know how to draw points. To get to the point -2, 3, I go 2 to the left and 3 up. There's my point -2, 3. And the point 5, -7 means go 5 to the right. So here's 1, 2, 3, 4, 5. And -7 means go 7 down. Remember, your first number is always left or right. Left if it's negative, right if it's positive. Your second number is the up and down number from that point. Positive up, negative down. So here we're going down 7. 1, 2, 3, 4, 5, 6, 7. So here's that second point, the point 5, -7. And obviously then this is my line. Connect the 2 points, I have a line. What we would like to be able to do is find the equation of this line. And in order to write the equation of line, there are 2 things that we'd like to know. We'd like to know its slope, and we'd like to know its y-intercept. We'll go on a little bit further in that, but let's first talk about how can we find the slope of this line? What can we do to find the slope of this line? And that's the other method of finding the slope. I didn't give you an equation, I just gave you 2 points, so I have to use the slope formula, y2 minus y1 over x2 minus x1. And this formula is so important that you must know it by heart. You can't go into any test or any example without knowing this formula. If you're doing graphing, you must know this formula. It really is telling you what I said rise over run is, because y2 minus y1 is telling you how much you're going up from point 2 on the y2 minus y is telling you the rise. And the x2 minus x1 is telling you how much you're going across, so it's the run. So it's really giving you rise over run. The best way to do this, I think, is to label one of your points as your x1, y1. And it doesn't matter which point you take as the x1 and which you take as the y1, as the x2. You just specify. Let's call this point 1. Let's call this point 2. So then the x1 with the y1 will go with point 1. The x2 with the y2 goes with point 2. Don't mix it up. Don't do x1 with y2. That doesn't work. x1 has to go with y1. x2 has to go with y2. And remember, the x's are the first numbers, the y's are the second numbers. So if I put these numbers into the formula, my y2 is -7. Remember, I've labeled it. I always like to label it so I don't make a mistake, because it's easy to make mistakes here. My y1 is 3, so my top becomes -7 minus 3. And my x2 is the 5 minus the x1, so it's minus -2. Now you have to be careful with your numbers. If you have trouble, take out your calculator. And in your calculator, do -7. Now remember, when you're putting in a negative number, you have to use that special negative. It's not the subtraction sign. This is -7 subtract 3. And that gives you -10. On your, and you can do this on your calculator as well. 5 subtract -2. Remember, this is the subtraction sign. This is the minus. We know, though, when we have two minuses, they become a plus, so that becomes 7. The slope of this line is -10/7. And don't convert it to a decimal. Leave it as a fraction. It can't be reduced. If I could reduce it, I would reduce it. What is that telling me? It means if I start, let's say, at this point, right over here, there's one of the points on the line, and I go down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Be nice if I had graph paper so you could see it clearly. And then over 7, I'm running 7. 1, 2, 3, 4, 5, 6, 7. It gets me to another point down the line. That's what the slope is telling us. Jennifer, was it you who had the question?
Yeah. Now this I understand. I
Okay.
specifically wrote one down because it just mind boggled me because at a point you have to divide by 2 in this one, and I don't understand why.
Okay, do you want to, can you have that particular
Yeah,
problem?
I have the problem is -8.
Yeah.
And then the other one is -6. Close parentheses, -18, +6.
Okay.
So
Okay.
then what I did was it was 6 minus
Okay.
-6.
Tell me which was your X1, which was your Y1. Let's do that.
Okay, so the 8 I did X1,
Okay,
and then my 6 will be Y1,
good.
and then my 18 is X2, and my +6 is Y2.
Okay, perfect.
Then you write it down. It was 6 minus -6.
Correct.
Then line 18, -18 minus 8,
Minus,
-8.
right.
That equaled to 10, I mean to 12 over -10.
Okay, wait, let's be careful with this. Okay, 6, this becomes pluses. So 6 plus 12
Is
6 plus
12.
12. And this also became pluses, so it was -18 plus 8, and you said it was
-10. So this is where I get confused. At this point,
okay.
you divide by 2 because you could make this smaller, right?
Right, this is, we try, it's not wrong to say this is the slope, but I think on Delta Math, they asked you to
They
specific,
want it to be specific.
they want you to reduce it.
Mm-hmm.
So reduce it, is there anything that you can divide the top and the bottom by?
By
2.
2.
Right, so that becomes 6 over -5. And you could write that as 6 over -5, You could also write it as -6/5 because it doesn't matter if the minus is in the bottom or on the top. Or you could just write it minus in front of the whole fraction. These all mean the same thing, and they're all acceptable. But the only reason you had to do that is because if a fraction can be reduced, they want it reduced. They want it simplified.
Okay.
And if you put it into your calculator, you know what? I wish I knew which calculator you have. But
The two line.
you have a 2-line. Most of those 2-line calculators have fraction buttons. And if you use the fraction function on your calculator, it will reduce it.
Okay.
Okay. If you send me a picture of your calculator, I probably could give you instructions what to do.
Okay, I'll send it to you.
Okay, so I'll do that after class. Are there any other questions before I go on to the next step? Okay, so then I'm going to continue from here. Now, we're spending a lot of time talking about slope. And we saw slope really told us a lot about lines. Number one, slope tells us whether the line is slanting down or whether the line is slanting up. Remember, when the slope is negative, as you go from left to right, you're going down. You have a descending, and it's easy to remember. Negative, you're down, you're going down. As your slope is positive, hey, when something is positive, they're on an upbeat. Again, it's always as you're going from the left to the right. So that's number one. Slope tells you the direction of the line, how the line is slanted. We also saw that we had two special lines. Two special types of lines. One type of line that I talked about on Tuesday was a line that looked like this, a line that goes straight across. It's not rising, it's not falling, it's flat. It's called horizontal. A horizontal line has a slope, let's call it M. The slope M is 0. Makes sense. It's not going up, it's not going down, it's just going straight across. It's not rising, it's not falling. Its slope is 0. Remember, 0 over any number. The 0 is in the numerator. It could be 0 over 1, it could be 0 over 2, it could be 0 over 100. It's not 0 over 0. There's no 0 in the denominator. That always equals 0. A horizontal line has a slope of 0.
Professor, even on the delta yesterday, I got a problem, and the answer that I got was, I think it was 1 over 0. And I put in 1 over 0, but it says undefined.
Right. I'm going to get to that in a second. That's not this line. That's not this line. This is something like 0 over 1 or 0 over 10. Any number over 0 equals 0. Where is the 0, Stacia? Where are you seeing the 0?
At the top, the numerator.
Anytime you have a 0 on the top and not a 0 on the bottom, any other number except 0, that comes out to be the number 0. And that's the slope of a horizontal line. We also mentioned that we know what the equation of a horizontal line is. When we have a horizontal line, the equation is always y equals. There's going to be a y in the equation. There's no x in that equation at all. If you have an equation that only has the variable y in it, and they ask you to graph it, It means you're graphing a line that's horizontal. And it's always going to be y equals some number. Now, what's the number? It's whatever the y is of any point on the line. So the easiest point to find is the y-intercept. Notice the y-intercept is 2. So the equation of this line would be y equals 2. So a horizontal line is a very simple but interesting line to look at. It has a slope of 0, and it has an equation y equals a number. Special line. Okay. Any question about this? Now I'm going to go into your case, Stacia. Let's say instead of your line going side to side, your line is going up and down. It's what's called a vertical line. So horizontal means side to side, vertical means up and down. A vertical line slope is undefined. The word undefined means a number, really it means a number that doesn't exist. And the only kind of numbers, the only kind of operations that we're never allowed to do with our numbers is to divide by 0. It means we have some number over 0. It's where the 0 is in the denominator. Never give an answer with a 0 in the denominator. If you get a 0 in the bottom, it means there's no answer. This doesn't have an answer. If I ask you, what's the slope of this line? Doesn't exist. You want to use the term undefined, you can use the term undefined, but undefined means it does not exist. So if you came out with a 0 in the denominator, then instead of writing a number for the answer, don't write 0 as the answer. Your answer is undefined. Is that clear, Stacia?
Yes.
Okay. So there's a very big difference between horizontal lines. They do have slopes. A horizontal line has a slope. It happens to be the number 0. 0 is a number. But vertical lines, they don't have slopes. Their slopes are numbers that don't exist. They're undefined. No such thing. If I ask you what is the equation of this line, not what the slope of the line, the slope doesn't exist, but it does have an equation. The equation of this line is x equals a number. Vertical lines don't have any y's in their equation. They only have x's. And the x's, whatever x is on the line, they all have the same x value. In this case, it's 1, 2, 3. This would be the line x equals 3. So if you understand that and remember that, it's very little work. You want a horizontal line, you write y equals a number. You want a vertical line, you write x equals a number. No other variable. Any line, any equation that has both an x and a y is a slant line. Vertical lines never have y's in their equation. Horizontal lines never have x's in their equation. If you have both an x and the y, all the lines that we've been dealing with had both x's and y's, that's why they were slanted lines. Okay, I think this pretty much takes us to where we had been on Tuesday. And I'd like to go a step further. Now, if somebody has a question before I go further, ask it now so I can judge that I'm okay going further. see there. Let me-
Professor, could you repeat where you said vertical line doesn't have a X? Something like that, or
No,
doesn't have
a
a Y?
vertical line doesn't have a Y, it only has an X. A vertical line always has an X and only has X in the equation. A horizontal line only has Y in the equation.
Okay.
Let's do an example. I'm going to give you a couple of minutes to try this. Suppose I gave you, here's my graph. Okay, and I'm going to this point. I'm going to the point -2, -4. Okay, I know how to get to that point. -2 is 2 to the left, -4 is 1, 2, 3, 4 down from there. Here's that point, -2, -4. Here's the point. Question number 1. What is the equation of this horizontal line? This, you do a very good job at that. This is a horizontal line, a line that's going straight across. I want to know what is its equation and what is its slope. Anybody want to give me an answer?
-2, -4.
Okay, Shira, you
The
gave
horizontal line should
me the point. That's not what I wanted. The point is -2, -4.
the horizontal line is
Equation of the
2,
line,
-2.
and what is the slope of the line?
-4 and 0.
Isn't the horizontal line -2 because it's only the Y?
Okay, so what is the y here?
-4.
I mean -4.
Right, the equation is y equals -4. When you write what the equation is, the equation is really giving what the feature is. An equation has to have two things. It has to have a number. It has to have an equal sign, but it also needs a variable. Some equations have two variables. Some have x and y. But lines that are horizontal only have one variable. What's the variable that they have? What do we say, a horizontal line? What kind of variable does it have?
X.
X.
A horizontal has an x.
Y.
It only has a y. The reason is because if you look at all the points on this line, here's the point -2, -4. Here's the y-intercept, that's 0, -4. Here, let's say I go 1, 2, 3, 4, 5, 6 out, and then go down here. That'll be 6, -4. Whatever the x is, I can take any different value for x I want. But the y value, since it has to be horizontal, always have to be equal to -4. So the equation is y equals -4. What is the slope of that line?
There is no slope, it's a straight line.
0.
Right, the slope is 0. How do I know the slope is 0? Because it's a horizontal line, and every horizontal line has a slope of 0. So if I give you the point -2, -4, and I ask you what is the equation of the horizontal line, I know the horizontal line is going to be y equals a number. All I have to do is look at what is the y value on the point. It has to be that number, y equals -4. Okay, let's do the next question. I'm going to redraw it over here because it's pretty messy over there. Here's again, my point, -2, -4. Let's talk about the vertical line through that point. That means a line that goes up and down. What is the equation of that line?
X equal -2.
Perfect. It's x equals -2 because we know a vertical line has only an x. It's x equals, what is the x equal? It has to be -2 because on the point it's -2. And what's the slope?
0.
Undefined.
The slope?
Oh, sure.
Undefined.
Undefined. 0 is the horizontal. It's just you have to memorize these things. Undefined is the slope of a vertical line. 0 is the slope of a horizontal line. A vertical line doesn't have a slope. It is undefined. Because it gets, if you put in the points, you get 0 in the denominator.
You said 0 is the slope of a vertical line?
Say it again. You said you have to talk
0
louder,
is
John.
the slope of the vertical line, you said?
The slope of a vertical line is undefined.
Okay.
And the slope of a horizontal line is 0. You just have to put it in your notes big and bold. Put it in the inside of the front flap of your notebook. A little bit later in the term, I will send you out what I call a study guide for Math 136. And I will put in all these important bits of information that you have to remember. Some of these things, it's just a matter, you could figure it out, but it's easier just to memorize this information and have it on hand. Okay. Now, let's go. Let's go back to this whole concept of slope. I want to let's go back to our slanted lines. Suppose I have two lines. I have a line that looks like this. Let's call this line 1. And another line that looks like this. Let's call this line 2. What do those two lines look like? What do we call two lines that look like this?
Parallel lines.
Parallel lines. What does the word parallel mean to you?
Evenly apart?
Right.
Equal to each other.
Yeah.
Run along each other without intersecting.
Yeah, say it louder, Corey. That was beautiful.
Run parallel. They run next to each other without intersecting.
Right. No matter how far you would extend these lines, they'd always stay the same amount apart. So they would never cross. They would never intersect. The correct term is intersect. So parallel lines are lines that never cross each other. And I can't say that these are parallel lines even though they don't cross each other, because if I would draw the lines longer, eventually they would cross. When we talk about parallel lines, we mean the two lines, no matter how far I would draw them, could extend them again further and further and further. No matter what, they would always stay the same amount apart, which means they would never intersect. Okay, let's talk about slope of this line. Remember what the slope is telling you. The slope is telling you how much the line is slanted. It's telling you how much you go up as you go across, right? That's what slope is. But really, it's giving you an idea of the slant of the line. If I say the slope is 3/2, it means that if I go up 3, I have to go over 2. It's telling you the rate at which you're changing the x's and the y's. Okay? What would you say about, well, let's talk about the slope of a, where's the common use of slope? Ski slope. What if you had two ski slopes that were parallel? What would you say about the actual slope or slant of those?
That they're the same?
Wouldn't they have to be the same?
Yeah. So you're saying the slope for line 1 and line 2 are the same thing.
That's exactly what I'm saying. It so makes sense. When the lines are parallel, then their slopes have to be equal. I'm not writing a whole sentence. I hope you understand what I said. Parallel lines have equal slopes. It makes sense because if they're parallel, they have to be slanted exactly the same amount, and therefore their slopes have to be the same number. And actually, I could just give you the equations of two lines, and you could tell me right away if those lines are parallel or not. Let me give you an example. Here's my equation for line 1. It has nothing to do with what I had just graphed before. Here's equation line 1. Y equals 3/2 x minus 5. And here's the equation of line 2. Two x minus 3y equals 18. Okay? I'm going to give you a minute to find the slope of each of these lines. I want somebody to give me the slope of line 1 and somebody else to give me the slope of line 2. I'm going to give you a couple minutes to do that.
Can I try to solve it?
Okay, does somebody want to tell you, Emma, was that you? You want to tell me what the slope of number 1 is?
So here's what I was going to ask. Isn't the slope already there, 3/2?
Right.
Okay.
No work required on number
Yeah.
1. How did you know that?
Because it's already in fraction form in front of the x.
Right.
So
Well, it's already y equals.
y equals
That's
mx plus b form, right?
y equals mx plus b form. So there wasn't any work to be done. The slope for line number 1. Notice I'm not drawing the line. I'm not looking. I'm doing this all totally algebraically. Algebraically means from the numbers. I'm looking at the numbers. Does somebody want to tell me the slope of number 2? Let's hear somebody else try.
It will be 2x over -3.
Okay, I see you have a helper there, Kashira. Okay, what should I do? Can I look at this and tell you what the slope is right away?
Set that baby up.
What should I
Take
do?
away. Subtract 2x on both sides. 2x and 18 minus 2x. Yeah.
Okay, so this leaves me.
Then it'll be -3y equal 2x plus 18.
Is it, watch your sign.
I mean -2x, yes.
This is where it's so important that you have to be careful with those lines. Okay, are you finished? Is this good? You saying the slope is -2? Go ahead.
No, divide by negative
Right.
3.
Okay, so what does that equation come out to be?
Y equals -2 over 3,
-2 over,
-3,
right,
plus 6.
okay. So what is the slope of this line?
Can you repeat that again?
What is the slope of this line?
-2 over -3.
Can we simplify that?
No.
Remember, negative over negative,
The positive.
that you can do. Two negatives make a positive, so it's 2 over 3. Okay, are these two lines parallel?
Yes.
How many?
No.
No, why not? Because this is
Because they're not the same thing. You have 3/2 and you have 2/3.
3. They're not the same slope. They look similar, 3 over 2 and 2 over 3, but they're not. This is the 3 on top and the 2 on the bottom, which means you're rising 3 and running 2. And this is 2 over 3, means you go rising 2 and 3 and running 3. So unless the slopes are identical, which means that you have to reduce them, if they're, because if you sometimes you don't know if the fractions are the same. You look at them, you look at the slope, the number in front of the x, and if they're exactly the same numbers, that means the lines are parallel. But if those slopes are not exactly the same number, then the lines are not parallel, which means that if I went to draw these lines, these two lines eventually would meet. So just looking at the numbers, it's positive. No, it's a -18 divided by a -3 is a +6.
No, in the original problem, it was 2x minus 3y equals 18. So it would be -3y.
Oh, I'm sorry, you're right.
Plus 18. Yeah.
Thank you, thank you, thank you.
Mm-hmm.
That's why I need you there. I need you guys there to keep me on the straight and narrow. Okay. I'm going to tell you, we're almost finished with class, so I'm going to start right here. By the way, I didn't give you homework for tomorrow. I gave you homework that's due for on Tuesday, because there's a lot more that I want to cover about this whole concept. But I would like to say one more thing that we can tell from slopes. Look at what we've so far been able to tell from slopes. Number one, if I said the slope was 0, I knew my line was a horizontal line. Number two, if I said my slope was undefined, I knew I was dealing with a vertical line. Also, if my slope was a fraction or any number, it wasn't 0, it wasn't undefined, some number, if it was positive, it told me the line was going up. And if my slope was a negative number, it meant the line was going down as I go from left to right. And also, we saw now, if we had two lines, we could tell if the two lines are parallel by looking at the slopes. If the lines are parallel, their slopes have to be exactly the same number. If they look similar, but they're not exactly the same, then they're not parallel. The only difference could be is one is you have to reduce them. Make the slopes in simplest form so you can compare them. They have to be the exact same number with the same exact sign in order for the lines to be parallel. Now, there's one other thing we can tell from slopes. And this is something that you're just sort of going to have to take on faith from me. It made sense that the lines that are parallel have the same slope. It just makes a lot of sense. But I'm going to talk about something called perpendicular lines as well. When we talk about perpendicular lines, we mean if we have the two lines are intersecting, and they're intersecting at what we call right angles. They make these square corners. When we talked about our rectangles, the lines, the sides of the rectangle are perpendicular. That means the angles that they meet in are always 90-degree angles. It happens to be, if you look in the real world, in construction, let's say, in houses and in office buildings and everything, most rooms, most desks, most boards are rectangles, and they're, let me make this up. If you notice, this side and this side are perpendicular. These lines are perpendicular because they're meeting at right angles. They're making square corners. Very important to know if lines are perpendicular or not. And it's interesting. You can tell this if two lines are perpendicular from their slopes as well. The lines will be perpendicular if their slopes are what we call opposite reciprocals. So what does that mean? Let's say the slope of line number 1 here is 3/2. Then the slope of line number 2, if they're perpendicular, has to be, well, let's see what the word opposite reciprocal means. Opposite means different sign, the opposite sign, and reciprocal means flipped over. Flipping the 3/2 over will give me 2/3, and it would have to be minus because it's opposite reciprocals. It's not just flipping over the number, but I need the slope to be, it has to be flipped over and the opposite signs. Let's look. Let's say I told you the slope of one line is 3. What would the slope of a perpendicular line be?
-3.
Well, let's think about it. There are two things I have to do. First of all, this isn't a fraction. I told you I also want slopes to be fractions. What is 3 written as a fraction?
3/1.
It's 3/1. So what would its opposite reciprocal be?
1/3.
Close. Opposite.
Negative
Negative
1/3.
1/3. You see what I have to do? I have to flip the fraction over and switch its signs. Let's say I have a slope that is -4/7. What would a perpendicular line have to have the slope of?
7/4.
+7/4. Perfect. Because you have to flip it over and switch its sign. This is negative, you have to make it positive. You want to put a plus there, you could, but usually we don't. And you have to flip it over.
Okay, that makes sense.
Okay.
How are those questions going to be like presented on Delta Math? I think that's something that also throws me off is I'm not always 100% sure what they're
Okay.
asking
Okay,
within.
I would say don't start the problems on Delta Math today, because I really have to do more work on this before you can do today's homework. The homework that's for Tuesday. Okay? We're going to, does anybody have a question as to what we've talked about today? We talked about, Lissa, what time is your tutoring session? You want to put it on the chat?
It's from 2 p.m. to 6 every day.
2 to 6, and does everybody have your, can you put on your chat your,
They have to go to the learning center. So they have to go to like the Mega Everest website.
okay,
Go to the Mega Everest website, and then when they go to the Mega Everest website, they go to the learning center. And it should be like a self-explanatory from there.
okay. Thank you.
I'm gonna put my email down in the chat if you guys
Oh, that's great.
want to basically hit me up.
Okay. Okay, so let's go back. We talked a lot about slopes. And the last thing we talked about the slopes is how to tell if lines are parallel or perpendicular. And we're not telling you how we're finding the slopes. I'm telling you what the slopes of the line are. We haven't gotten that far. We'll eventually get that far. But right now, I'm going to be telling you the slopes of two lines. So let's say I tell you the slopes of these two lines. Slope of line 1 is 5/4. The slope of line 2 I should put equals, is -8/10. Okay, that's all I'm telling you about these two lines. And my question is, are the lines parallel or perpendicular or neither? What does neither mean? Neither means that they're neither parallel nor perpendicular. They just lines that eventually cross, but don't cross at right angles, which is what most lines do. Most lines are neither parallel nor perpendicular. Okay, can anybody tell me what they think these lines are? Are they parallel, perpendicular, or neither?
I kind of think they're perpendicular because
Want to give me a good reason?
because if you flipped 8/10, right? And you reduce those, like if you put 10/8 and reduced.
Well, I would even reduce it before I flip it.
So let's reduce it before we flip it. So that's 4/4.
Right. Usually, look at 8/10 is not simplest form. We really want our slopes to be in simplest form. What would it be in simplest form?
-4. I mean, yeah, -4/5.
Right. Because I can divide the top and the bottom both by 2.
Mm-hmm.
Now, what do you see?
Now I see that they
The
are
opposite.
Yeah.
Right,
Yeah.
they're opposite reciprocals. They're flipped over. This is 5/4, this is 4/5. And their signs
Signs are
are
changed.
opposite. Whenever you have perpendicular lines, one of the lines has to have a positive slope and one has to have a negative slope. That makes sense because you want them to meet at right angles. So they have to, so it doesn't matter. One of them is going to be positive, one of them is going to be negative, but the fraction is going to be flipped over. That's why it's so important that you have it in fractional form. So that's something that we just learned now, how we can tell if lines are parallel or perpendicular. Okay, I'm going to stop the recording right here because I'm gonna